Good afternoon. My name is Todd Evie. I'm the manager of project review here at the Commission. I'll be the moderator for today's webinar. All participants are muted, and we ask that you disable your camera when joining. The chat box is available for questions that can be used at any time. We ask that you address questions in the chat to everyone so that all the presenters can see the questions as they come in. This session is being recorded, and the recording will be made available in several days after the webinar. Today we're going to have two presenters, Mike Appleby, supervisor of groundwater, and Scott McFeeters, a hydrogeologist in the project review section. At this point, I'll hand the webinar off to Mike Appleby.
Thanks, Todd. I am Mike Appleby. I am the groundwater supervisor at the Commission. Thank you for joining us today for part 3 of our 3-part webinar series regarding AHEs. Today we're going to have a session that's about 90 minutes long. It's going to have about 75 minutes of presentation, and we expect the last 15 minutes to be for questions and to answer those questions. We will have a certificate of attendance for those that have attended the live webinar. We will provide instructions for how to get that certificate closer towards the end of this presentation. Today we're going to talk about the Commission developed voluntary action plans, how we utilize the data that a project may already have in existence to identify data gaps and to develop methods to resolve those data gaps. So we're going to go over a couple of examples of that today, and that's mostly what Scott McFeeters is going to talk about. And Scott has been working on the Public Water Supply Assistance Program for several years now and has been developing most of the action plans that the Commission develops. So with that, I'm going to hand it into, or turn into the description of the action plans themselves and what we consider an action plan to be. An action plan is not required, but we do recommend that projects that aren't eligible for the Public Water Supply Assistance Program to develop their own action plans. We think that they're useful to help summarize the data that you have available. They do help to identify the data gaps and then provide a plan and scope of work for how to fill in those data gaps. These action plans also can be a good start on the AHE that you're going to develop as part of that process. So as I said, the Commission does develop voluntary action plans for eligible Public Water Supply Assistance Program projects. And those projects are mostly what Scott has been working on. But for the projects that aren't eligible for that participation, the consultant can complete that action plan and certainly can talk to Commission staff at any point through this process if they have any questions about how to develop an action plan, whether something is a data gap or not, and what types of methods may be acceptable for filling in that gap. So at this point, I'm going to hand it over to Scott so he can talk about a couple of examples of the action plans that we're doing.
All right, thank you, Mike. Yeah, my name is Scott McFeeters. I'm a hydrogeologist here at the Commission, and I thank you all for joining us this afternoon. And as Mike alluded to, we're going to talk about the voluntary action plans that we are preparing here at the Commission. Over the past 3 years or so, I've been involved in quite a few of them. We are generally preparing about 8 to 10 of those a year, and we're going to give you some details on about 5 of those plans here today. But before we get into the nuts and bolts of the plans, I want to just go over a little bit of background on what we do as far as preparing to develop the action plan. So keep in mind the format that as we go through these descriptions, our goal is to answer the 3 principal risk factors that you've heard probably here in several of the webinars. You know, one is the withdrawal going to be sustainable at the requested rate? Are there impacts to other users, and are there impacts to the environment? So those are the 3 things we're going to look at as we develop a plan. Our goal is to identify that, hopefully, that there is low risk to renewing the project at the previous rate, and hopefully that we will not identify any data gaps. If that's the case, you know, the possible outcome is that the user could simply use our action plan to renew at the as their evaluation, hydrogeologic evaluation, to renew at the previously approved quantity. But as we find that's not always the case, we will, if we do identify data gaps, we will call those out in the action plan, and we'll provide some guidance and some options that the public water supplier can then do some additional testing to fill those data gaps. So we're going to talk about those. Always there's the option that if the project sponsor wants to complete an aquifer testing plan, that's always an option, but we're not going to really talk about that today, but keep in mind that it is something that is available. So what does an action plan process involve? So again, we've mentioned this is a voluntary process. It's not something that is required, but what we will do is if we receive a request to participate in the Public Water Supply Assistance Program, we'll go ahead and set up a meeting date, and we'll generally set that meeting probably about a month in advance, because keep in mind, if you identify that you want to participate, we don't really have all the information at the tips of our fingers that we will know about your well and all that. So we got to do some homework. And as part of that process, we will gather some data once we set the meeting, and we prepare what we refer to as a regulatory and environmental overview. So we'll look through our files, we'll pull out any historical testing data that we have. Most projects are submitting quarterly data to us as far as withdrawal and water level records. So we'll pull those data, put together some graphs. We also do a preliminary ecological screening to identify what sensitive features may be in the area. And we'll review the docket, the existing docket, to look at any conditions that may come into play through the renewal process. So all that is put together in this regulatory and environmental overview, and we bring that to the meeting. We'll hand that out. We'll review that with the sponsor during the meeting. We'll also talk to them about how their system operates, you know, what wells they have, what their typical use of each well is, and the demand on their system. We'll go through the regulatory overview we have, and we'll try to identify any additional data needs that we may have. Certainly we'll take a walk through the site too. We'll look at the well, we'll look at the setting that the well is in. It's always good to put eyes on the features that we're going to be working with and trying to develop a plan. And often we'll follow up the meeting then with the data request of anything else we've identified that we need to write the plan. So there's some work up front prior to actually getting into the action plan. But once we do that, that's where we'll dig into the data. We'll try to develop a site conceptual model for the hydrogeologic system out there. We'll then take a look at the 3 risk factors and use the data that we've gathered and has been provided by the sponsor. We'll use that data, try to identify any gaps, and ultimately come up with some conclusions and recommendations for the path forward for a renewal. So with that, we're going to go ahead and start looking at some of our examples. Like I said, we've put together 5 examples we're going to go over in detail today. The format that we will go through, we'll have about 8 slides for each of these examples. It's a similar format, so try to get you to think as we go through these examples. So this first slide we're going to put up for each of these examples is just going to be some high-level stuff that we look at as we're beginning to prepare for the action plan development. So site one, well one, we're looking at, it was a well that was approved in 2008. It was approved at a withdrawal quantity of 130,000 gallons a day. So some of the initial information we'll look at, the well, this well one is within a SRBC water challenged area. And if you're not familiar with that term, we have a groundwater management plan that identifies water challenged areas and potentially stressed areas that these areas are identified because there may be some limitations to developing water. So again, unfortunately, this site does fall within one of those categories. It's just something we need to be aware of as we start this project. Another thing we'll look at, I've got listed here, there is an aquatic resource class 2 stream near this well, and the aquatic resource class designations are something that's called out in our low flow protection policy as far as identifying if pass-bys are needed on surface water features. So it does not necessarily directly come into play here, but the reason I wanted to call it out is because it gives us an idea of the drainage area of this stream that is proximal to the well. So an ARC 2 setting suggests it has a 10 to 50 square mile drainage basin. So again, just giving you a big picture view of what the drainage is in this proximal to this well. Another thing just to be aware of, there's a wetland nearby. So overall, going into this project, just a couple of high level things we can deduce is that there's a potential limitation for the recharge, and there's some environmental resources that we need to be aware of. So then we start looking at the data we have and what data we are able to use to answer the 3 questions that we're looking at to address the 3 risk factors. So I'll quickly go through this. As far as sustainability, we're going to look at groundwater availability analysis. We don't often see this, but there was a good availability analysis conducted in the past for this well. So we have that to look at. There is a historical 48-hour constant rate test with a good hydrogeologic report that we had in our files. So we'll take a look at that. Also, we have a good well log that clearly calls out the water bearing zones. That's an important aspect that we're going to look at for sustainability. And we have 13 years of operations data as far as withdrawal data. We have less water level data, but again, the key is that we're trying to, with the operational data, we want to have withdrawal data combined with water level data to see what stress may be placed on the well or the aquifer. So in general, that's a good data set we have to start looking at for sustainability. With respect to impacts to other users, the historical test did have a good monitoring network associated with it. There were 8 other wells monitored. So again, we don't always see a robust network like that, but so that's good to have for this well. Another piece of useful information is a public water supply distribution map to show where the public water system is supplying water and where there may be areas where there's private wells being used. And we also have the state database. This facility is in Pennsylvania, so we have the PWSAP database, and also just typically do an aerial photo review to look at the area. As far as sensitive environmental resources that might be there, we do have a stream and a wetland that were monitored during the historical test. So that's excellent data that we have there. And we do take a look at the current designations of the stream and the wetlands to see if there's any special protection classifications there. Plus we do the PINDY screening for the sites in Pennsylvania. So that's the data we have available. So let's go ahead and look at as how we start digging into developing an action plan. And again, the first step here is we want to try to understand the big picture. So we start to put together a conceptual model of the hydrogeologic setting for this well. If you look at the screenshot I've got here on this slide, I don't expect you to be able to read it, but I'll explain what it is. It's a shot of our Ahe form. That is what you would complete if you were filling out our alternative hydrogeologic evaluation form online. There is a link that I've kind of highlighted there in yellow, and if you click on that, I think it's titled Instructions. If you click on that, it brings up an outline that we've prepared to give you guidance on how to develop your conceptual model, or how to write up your conceptual model. There's 4 primary headings there, and I've got a bullet here for each of them. One is formation, one is your hydrogeologic description, another is looking for information on the flow system, and then the 4th is potential boundaries. So as we develop this for well 1, I'll just point out a couple of the key factors. Is the formation is shale, the Gettysburg Formation, and one of the important features for this site is that the bedrock strike is from southwest to northeast. And when we look at the results of the aquifer testing, that's significant because the drawdown that was detected or determined through the testing was primarily along the direction of strike. So that's an important feature to know. As far as the flow system, it's important for this site to know that it was confined, semi-confined to confined setting. And, you know, we do have the potential recharge boundaries with the stream. So overall, we're just starting to develop our conceptual model, and that's important information to know as we dig into answer our questions. So the first risk factor we're going to take a look at is the sustainability of the withdrawal. And the first part of analyzing that is to look at a desktop groundwater availability analysis. And as I indicated earlier, there was one found in our historical files. So what we did is we pulled that information up, and we wanted to confirm, look at it, see if it still makes sense. And the one that was on file identified a recharge area of 0.86 square miles. And the hydrogeologic report provided a description of how that was developed, and it was a structural basin that was defined by extending the primary water-bearing zone to the surface based on the known dip of the bedrock, and the area of influence was used to identify the topographic drainage that would ultimately be captured by the projection of that zone. So it was a well done recharge area definition, and we considered that to be acceptable. Recharge rate used by the consultant was referenced in literature. We looked at that and confirmed that that was a reasonable value. And we've also looked at what other users may be within your groundwater contribution basin. The area is not highly developed in the vicinity of the well. There are some other wells, but there's also a good coverage by the public water supply. So the ultimate conclusion here is that the previous availability analysis was reasonable, and there's low risk to the sustainability of the previously approved quantity. So that's the first half of what we look at typically for sustainability. Another consideration as we look at the sustainability is what will happen during drought conditions and the requested withdrawal, in this case, of 101,000 gallons a day. So the first thing we want to do is look at if we actually have any data for withdrawals occurring during a drought. Before I get too far into this description, I want to draw your attention to the graph that's provided. There's a lot of information on this graph, and as we go through the examples, you're going to see a similar graph on each of the examples. So I'll just take a minute here to explain what you're looking at. You'll see a purple line and a blue line across the majority of the graph. The purple line represents the 30-day average withdrawal, and that's tied to the primary y-axis on the left-hand side. The blue line are your water level measurements, and they are tied to the secondary y-axis on the right side of the screen. So you can see you have a decent record of continuous data there for those. You also see a couple other lines here. There's a red dashed line kind of in the middle of the screen. That represents a 90-day drawdown level that was predicted by the aquifer testing data. And you'll also see a greenish line towards the bottom of the screen, which will represent your primary water bearing zone. The last thing to point out, there's a shaded area vertically kind of in the middle of the screen. That represents a drought period. So the first thing we want to look at here is if we have withdrawal data and water level data during a drought. So we did have one drought period where we had some data. Unfortunately, the use of the withdrawal during that period did not approach the approved quantity. So in that case, the data really doesn't help us in the evaluation. Then we shift to looking at how the water levels are responding with respect to the 90-day drawdown. So what you'll see, the red line represents 296 feet is where the predicted drawdown should be. And if you look at the blue actual observation or operational data, it does not approach that limit. So ultimately what we can conclude here is that the operations data is consistent with the historical test data. The test data remains accurate in predicting that the water level data or the water level will not drop to the water bearing zone. And again, that's a key here, is we don't want to be exposing water bearing zones, which could potentially represent withdrawal that's not sustainable. So again, in this case, there's low risk to the sustainability. The second principal risk factor we're going to look at are impacts to other users. So the screenshot to the right will show the red outline, the red oval type shape is the groundwater contribution basin. Not a lot of development in that basin, you can see. So, the key is, are any of the developments or are there any of the wells in there that we need to be concerned about? So again, there was monitoring done during the test, and only one of the 8 wells showed an impact, and the impacts were along strike. So using that information, we can evaluate where other users may be that would be impacted by the withdrawal. As we go through the data available to us, it doesn't look like there's any or many users that could potentially be impacted. The one thing that did change from the initial approval of this well is there were 2 developments that were built in this area, and those underlie the blue shaded areas to the north and to the west. But the good thing here is that that blue shading represents the public water supply coverage, so there are no new users anticipated in those areas. So again, ultimately, the conclusion we come to is that there's low risk to impacts to other users due to operating well 1. So the third principal risk factor we're going to look at are impacts to environmental resources. As I mentioned, there is a stream nearby, there is a wetland nearby. The good news again here is that during that historical test, both were monitored and no impacts were detected. And that's an important piece of information to have as we try to rule out potential impacts to these features. We also look at the state designations. There's no special protections for either of them. And the third area we check into is the rare, threatened, and endangered species through the PND search tool. And in this case, no species concerns were identified. So overall, again, there's a very low risk factor to impacts to the environment based on the information we have available to us. So coming to the end of our data evaluation, we put up this summary screen. We've got the 3 principal risk factors. We kind of rank whether we have low, medium, or high risk. For each of these 3 factors, we've determined there's low risk. So what does that mean for a project sponsor? ultimately, the risks are satisfied with the existing data and that no additional evaluation is needed to move forward. In this case, we'll prepare this action plan, we'll write it up, we'll deliver it to the public water supplier, and they can choose to use our evaluation as their AHE. So no additional work would be needed, and they can just submit that as part of submit to us as part of their renewal to satisfy the AHE requirement. So that's a good story. You know, we do these action plans, can come up with different conclusions. As I progress through these, or as you know, Mike and I talk about these different sites, I'm going to kind of progress from what I'll refer to as this being a clean action plan, where the data supports the approved quantity, previously approved quantity, to, you know, we'll get into a little bit messier action plans later, but we're going to go on to the second one at this point, and you're going to hear some similarities in this one, but there is a difference in the conclusion we come to, and we'll talk about that in a few minutes. But well 2 here is a well that's been approved since 2003. It was approved at a higher quantity. We're looking at 350,000 gallons a day. Good news for this facility, again, some high level stuff. It is not within a water challenged area or a potentially stressed area. And if you actually notice on the right side of the screenshot I have there, it is proximal to the Susquehanna River. So it actually falls within the Susquehanna River at this point is an ARC 5 designation. Do need to be aware that there is a wetland and a small stream close to the well. So again, the high level picture as we're moving into this, it looks like we may have a potentially high yielding aquifer, but there are some environmental resources to be aware of. So again, the same deal here is we're going to gather our data before we start and try to see what we have available to answer the questions. So in the case of well 2, we do have a 72-hour historical aquifer test. There is what I'll refer to as a hydro report. It's not as detailed as the one we had for well 2. So staff did have to generate some of the graphs and some of the analysis that we used in our evaluation. There was a well log available. The aquifer is an unconsolidated aquifer, so that was good to note. And we do have some operational data, 18 years worth. Only 4 years of water level data, but again, that's better than nothing. As far as impacts to other users and to the environmental resources, the one thing different from well 2 compared to well 1 is that we didn't have surface water monitoring. So we'll talk about how we addressed that. We did have some other wells monitored, so we did have that data available. And again, some of the same resources that we had for well 1, we had for well 2 to answer these questions. So starting to dig into the plan, trying to understand our conceptual model. The formation we're dealing with here, again, is an alluvial sand and gravel aquifer. The well log did not show any confining layers, so we're looking at a unconfined aquifer. You notice from the water levels I provide there, the level in the well compared to the level of the river is really close, so it's a pretty flat water table out there. Potential boundaries, you have the river to the east and a wetland as well to the east, and then the smaller creek to the west. So the big picture is you probably got a fairly prolific sand and gravel aquifer, but there are some environmental features that we have to take a look at and consider. So looking at the sustainability question, we'll look at the desktop study, the groundwater availability analysis first. And I'm not going to actually spend a lot of time talking about this. You know, As I said, it's close to the Susquehanna River, so there's a large upgradient recharge area. If at this point, we also used a groundwater recharge rate that was derived from a stream gauge that was on the river. Ultimately, the conclusion that we come up with is there's a very low risk of this withdrawal not being sustainable, and in fact, there's probably more water, far more water than the 350,000 that was previously approved. So sustainability is looking good based on that. So then we're going to dig in and start looking at the drought data too. And a similar situation here with well 2 compared to well 1. We don't have a lot of drought data. There's actually there's 6 different drought periods depicted here in the graph, but only one of them did we have water level data available for. And the withdrawal during that drought period did not approach the previously approved quantity. So in that case, again, we're going to shift to the analysis of what the projected drawdown would be at 90 days. And I don't know if I explained this earlier. You know, the commission simulates what will happen in a well during a drought by projecting the drawdown to 90 days without recharge. So that's the significance of the 90-day line. So here in this case, the 90-day drawdown line shows up around 30 feet. Now I'll point out here, and I'm going to come back to this later, but that drawdown level is based on the test data. And if you notice the tested rate there, it was 1,678 gallons a minute. That converts out to about 2.4 million gallons a day. And if you recall, this well was approved for 350. So we'll talk about that significance later. But as we do this evaluation, again, the water level data that we have suggest that the water levels are not dropping to the 90-day rate. And in this case, we're looking at the top, not exposing the top of the well screen, since it is a casing and screen well as opposed to an open rock well. So in this case, again, the data we have suggest that the operations are occurring consistent with the historical tests. So there's going to be low risk to the sustainability at the tested rate here. So moving on to look at the impacts to other users. So what we did for this well, because we had some observation wells, we were able to put together a distance drawdown graph to estimate the extent of the radius or the area of influence. That information was not provided in the hydro report, but we were able to use the data provided to come up with our own. And in this instance, again, a very good aquifer. The extent of the drawdown was only to about 200 feet. When we look for other users within that area of influence, none were identified. And in fact, the public water service is provided to all residents within that distance and even a further distance close to the well. So the ultimate conclusion here was that there is very little or low risk to other users due to pumping this well. The third principal risk factor, again, we would look to address. The challenge that we had was that we did not have any actual monitoring data for the stream and the wetland close to this site. However, as we just talked about in the last slide, we were able to estimate an area of influence which does not extend very far from this well. So the reality is both of these features, the stream and the wetland, are more than 1,000 feet away. If the area of influence is only a couple hundred feet away, extending to a couple hundred feet, we don't expect impacts to these features. And in fact, the site visit helped out here too. If you take a look at the picture on the right side of the screen here, this was the wetland that we visited doesn't look very wet. And what we determined is the hydrology of the wetland is due to flooding of the river as opposed to groundwater contributions there. So all that was helpful. We kind of rule out potential impacts to those features. The database search with the state did show a threatened species within the river. I believe it was a mussel species. And again, we don't expect there to be an impact to the river. So for impacts to environmental resources, we classify these all as a low risk based, again, on the data and the hydro setting that we're looking at here at the previously approved rate. So to summarize where we're at as we're working our way through the action plan development, again, each of these categories, each of the principal risk factors, we've identified low risks of potential impacts at the previous quantity of 350,000 gallons a day. So again, the sponsor has the option here to simply use our action plan in the renewal process as their AHE, their alternate hydrogeologic evaluation. Now, I did allude earlier to there was going to be a difference in this project, and we'll move on to the next slide, because the difference comes because as we look at the data, again, we think back to the test, was completed at a rate of 1,678 gallons a minute, which is equivalent to 2.4 million gallons a day, but the project was previously only approved at 350. We do not have records of why only 350,000 was approved, but what we can conclude by looking at the data is that a rate higher than 350 is likely supportable. So the sponsor in this case has the option to request a higher withdrawal quantity up to the 2.416 million gallons a day, and we will consider that with our evaluation. They could use our evaluation in the action plan. There are a couple caveats I will throw out here just to be aware of. Again, we were evaluating or considering the threatened species at a rate of 350. So since they've pumped close to that rate in the past, we would suspect that no impacts would be realized, but we would encourage them or suggest they talk to the agency to make sure that if they wanted a higher rate, that there would be no impact to that species at the higher rate. The other thing, the last thing on the page here, we won't just simply say, yeah, we're going to approve 2.4 million gallons a day. We want to make sure that that is a reasonable quantity, and it has, it is a need of the system to request a higher quantity. So the data suggests a higher quantity may be approvable with existing data, but we will want to see a reasonable foreseeable need projection to confirm what quantity we would approve. So with that, I'm going to turn it back over to Mike, and he's going to take on the next slide.
All right, thanks, Scott. The example that I'm going to talk about is one that is in New York. This one is near the Shenango River, and there is a wetland not too far away from the well site. You can see from that picture that there's a couple other wells close by that are owned by the public water supplier. Again, this one's not in a water challenged area or a PSA. From kind of a high level perspective, we came into this project expecting it to be a fairly high yielding aquifer, you know, an alluvial sand and gravel type aquifer, potentially perched wetlands, but those were the types of things that we went into this looking at to see if we needed to evaluate and what the data would end up providing. It had been previously approved at 365,000 a day. So one of the things that we were going to ask the project sponsors what they really need to get out of the source. So in preparation for that meeting, we looked at the existing data that we had. And there was a historical 48-hour test And like some of the other ones, the hydro report wasn't all that complete, at least compared to what we would look at today. So we also had to do a 90-day projection to estimate where that test data would project the water levels to be after 90 days of pumping without recharge. There wasn't a lot of operational data to compare. It's kind of the similar situation. We have about 20 years of withdrawal data, but only a couple years of water level data. And a lot of that water level data was fairly old historical data. We see a common trend with projects that stopped collecting water level data in around 2007 and 2008. So there's often a fairly large data gap there associated with operational water level data. There were some wells monitored during that test, so that was a good thing for us to help evaluate what the type of the area of influence for the project. The public water supply, again, operates our distribution system within that area. And we also looked at New York State database to see if there's any other wells nearby. Similar to the other projects, there was no surface water monitoring completed during that historical test. And we also did the appropriate resource mapper and looked at current and designated uses for the wetland as well as the river nearby. So then we started to get into the conceptual model to assess what we might be expecting with this project. A couple of things that stood out is that it is a significant glacial outwash sand and gravel aquifer, but there's also about 100 feet of clay that was identified in the well log. So that right away is kind of an important signal to us that maybe some of the shallower features that we're normally concerned about, maybe they're not going to be too much of an issue with this project. That also means that with that level of clay that's there, that the aquifer may be confined. There again, limiting those shallow impacts. We would expect this to be a high transmissivity aquifer, but the depth to water here was kind of shallow. So even though there is a significant clay layer, we're not 100% sure that the clay layer is that continuous or if there's some other reason for the shallow depth to water that actually matches some of the water levels within the wetlands that are nearby. So that was something we identified fairly early on and needed to resolve as we worked through this process. Like the other projects, we looked at groundwater availability analysis. This one came out fairly well, even just looking at a more local basin. So even though the Shenango River was very close, we looked at a local groundwater basin to assess whether or not there was going to be anything that we really needed to look at and to look at it a little bit more closely. So we ended up with about 1.5 mile basin, and using the recharge rates for that, there was plenty of resource available to support this at the previously requested rate. So the availability didn't take a lot of time to look at, and we were able to move on from that fairly quickly. Sustainability analysis gets to be a little bit interesting when you start looking at the historical testing data as well as the operational data. So the historical testing data really does support a pumping at 395,000 a day because the historical test was on 500 gallons a minute. So again, we're looking at a higher test rate than what was eventually approved. And again, we don't know why the lower approval was provided. We just know that it was. So we also had to do some of those 90-day projections, and you can see that that's labeled on the graph with the red line consistent with the other graphs that Scott was talking about. And you can see the water, the withdrawal data there then below it. And some of that withdrawal data really indicates that when we have water level data, that they had only operated this well at about 181,000 a day. And that was during, we won't call that a drought period. It's not identified like that on the graphs, but we know that 2000 was generally fairly dry in a lot of areas throughout the Susquehanna River Basin. So it's reasonable to think that that was a fairly dry period, and they were able to produce it during that time. The water level data we had at that time appears to be static levels. So we didn't actually have any pumping levels for this, but at least we can see during those periods of the higher use, that there wasn't any groundwater mining, that there weren't any declining static level trends. So it appears like the 181,000 held up fairly well, even during what we would expect to be a dry period. You see some of the withdrawal data later on in the 2015 through present range. That withdrawal data varies significantly, but we don't have any water level data associated with it to really be able to assess whether or not those withdrawals are sustainable at the higher rates. So we had a little bit of a problem with this one because of this. If this project had been collecting that water level data from 2015 on, we might have been able to come up with a different conclusion. But right now we're thinking that the most we can reasonably support with the existing data is 181,000. So then moving on to impacts to other users to deal with these. It's a prolific aquifer. The area of influence didn't appear to extend too far. It said the testing data indicated less than 1,000 feet. That may have been because of the accuracy of the monitoring equipment. I probably would have expected the area of influence to extend this far, but there may have been less than a foot or so of drawdown, and it's possible the monitoring equipment wasn't sufficient to capture some of that. But regardless, the public water supply system covers this area. The other wells that are within the area are owned by the public water supply system, and there wasn't significant enough interference between these sources to be concerned about that. So we were able to move on from that one. Then we looked at the impacts to the environment. Now, this is another one that comes up because there wasn't any historic monitoring done during that original test. So what we have right now is we can look at this and say, well, the current operations generally look okay. You know, it's meeting its designated uses. I think that this did have an elevated regulatory standard at this wetland. So there is a little bit more attention that needs to be paid to this wetland. So the best we could do here is say, you know, there's probably a medium risk. We would expect that kind of that average use that had occurred a while ago is probably, excuse me. Sorry about that. That historical use was probably okay, and that, but to try to bridge that gap between 181,000 and 365 might be a little bit difficult. Sorry about that. So to summarize this, when we look at the risk potential for this, at present, at that historical rate, we can probably assess that 181,000 was okay, but we're just not sure because we don't have the water level data. So to bridge the gap between 181,000 and the previously approved quantity, that probably does represent a medium risk. Now that's kind of a guess, you know, so it's, but there's nothing there to really support it other than in historical testing. And we know that a lot of wells in these alluvial aquifers lose performance over time. So there might not be a problem with the aquifer, but there could be a problem with well performance, and that would need to be assessed. Impacts to other users is low risk, and then we get back to the impacts to the environment, and that again is low to a medium risk, depending on how the project would want to move forward with it. So we were able to provide two separate recommendations. The one recommendation was to accept our evaluation, and 181,000 would be acceptable. And if that was okay, then they could use our voluntary action plan as their evaluation and move on. But option two was that if they needed to get more than 181,000, then they would need to do a little bit of additional work. So this was a choice that they needed to make about whether or not 181,000 was acceptable, or if they needed to get up to that 365 level. So what we were saying is to complete some kind of operational testing to demonstrate that the withdrawal itself is sustainable, that the historical testing is appropriately characterizing the source, and to also evaluate the wetlands for the area. That would involve either installing a couple of piezometers or possibly a weir and a discharge channel for the wetlands. So hopefully by the time my next example comes up, I'll have speaking voice back a little bit better. So I'm going to hand this over to Scott to go over to the next example.
Okay, thank you, Mike. Get yourself a drink there. All right, the fourth example we got was, sorry, can you hear me now? Okay. Fourth example is back in Pennsylvania. We got a setting for well 5. But it was approved in 1992 at a rate of 101,000 gallons a day. This well is not in a water challenged area or potentially stressed area. It is in a relatively small headwaters setting. So that's something to be aware of as you start looking at this. There's also a wetland nearby, a stream nearby. So those are things we need to be aware of. So the overall picture going in, there's possibly some low recharge and some environmental resources that we need to be aware of. So looking at the data we have to answer the question, we do have a 50-hour aquifer test available. However, as we often find in some of these old projects, there was no hydro report with this data set, and there was no monitoring network. So that became a challenge as we reviewed this project, started preparing the plan. It was basically a single well test with some data sheets from the test. We had an okay well log for this, did identify water bearing zones, and we had some operational data, 22 years with 8 years of water levels. So again, as we move on to the other two principal risk factors, don't really have any monitoring data from the testing to help answer the question on impacts to others or to the environment. We did have a public water supply distribution map that was helpful to evaluate impacts to others, and we do have the PINDI results and current designations to look at as far as the other resources. So jumping into our conceptual model for this particular project was a little challenging, again, because we didn't have the hydrogeologic report. Through mapping, we were able to determine it is located is drilled into the shale, the Mulchunk Formation, but we don't have any site-specific geologic details. The water levels, a couple water levels we have in the well, compared them to the stream. So there's a offset in the depth of the water. However, after being at the site, the well is upslope of the stream, so the groundwater level probably mimics topography, so there's probably really no real separation in the distance. It's likely the groundwater table expressed as the stream. So we don't have a good feel for the flow system, whether it be confined or unconfined, but the boundary, potential recharge boundaries we identify are wetlands, streams in this area. So again, not the greatest model to begin with, but we're working with what we got at this point. So we start digging into our 3 principal risk factors. Look at the sustainability analysis. In this case, again, we don't have information on an area of influence, so we're going to make an assumption here that the well is going to intercept flow in the small stream that we have. So if we take the upgradient topographic recharge to a point of impact on the stream, we get about 2.5 square miles. Recharge rate, again, we had nothing to work with, so we go out and we look for whatever literature or resources are available. And one that we'll often use if there's a stream gauge nearby, a USGS stream gauge, they have values for part and aurora that give you a good estimation of the recharge in the area. So we'll pull that one. We'll typically use the part value, and people will ask us why, and because it tends to be the lower one. But if you actually read the documentation that introduces part in RORA, there is a reference that RORA tends to overestimate in some cases. So we tend to lean towards the use of the part value. As far as other users, the well is located in a rural area, a lot of forest in the groundwater contributing basin, but there are some users out there, so we have a low estimated use. So overall, the picture here, looking at the sustainability from an availability analysis, it looks like there's low risk as far as supporting the previously approved quantity. Now that brings us to the second part of our evaluation, and this is where some problems arise. So again, we want to look at what's going to happen during a drought to make sure this withdrawal quantity is sustainable. So if you actually look at the early part of the data set we have, the second drought period indicated by the shading, there was use of the well close to the approved limit, and we do have some water level data. However, if you actually look at where that water level is, it's down around 150, 160 feet. The 3 water bearing zones that have been identified in this well are at 60, 125, and 225 feet. So during this drought period, we were exposing 2 of the 3 water bearing zones. Something that gets more concerning as we look at this, the red line, again, towards the bottom of the graph, is the 90-day projected drawdown, which comes in at a depth of 254 feet. These data suggest that the water level is going to drop below all 3 water-bearing zones. So it's really not a sustainable situation. And to top things off, if you look at the life of this data set, the water level from early on to most recent, which is 2021 on the right side of the screen, the water level stays fairly consistent around 150, 160, which again is below 2 of your water bearing zones. If you look at the purple line, which is your withdrawals, what you'll notice is that the withdrawal is decreasing. And again, and while it may not be a definitive explanation, it's certainly a possibility that the routine exposure of these water-bearing zones is causing you to lose some of the yield of your well. And that's why you're seeing this decline in the withdrawals from this well. So that's raising a flag for us, and it's raising the risk level that our conclusion here is that the previously approved rate does not appear to be sustainable based on what we're seeing in the water levels and the use of the well. So we'll move on to look at potential impacts to other users. Again, it's a fairly undeveloped groundwater contributing basin to this well. You see a screenshot there on the right. The purple is outlining the contribution area. A lot of trees there in the southern half. But if you do look closely, there are about a half dozen residents within maybe 2,000 feet radius of the well. Again, if you recall, we did not have any monitoring network during the testing, so we do not have a good idea of what the area of influence of pumping this well is. So it's hard to say, or we can't say at this point, if any of those residents are truly going to be impacted by the pumping of this well. So again, the conclusion is that there doesn't appear to be a lot of users, but there are at least a half a dozen, and if you're one of those half a dozen, you're going to be concerned if this withdrawal is going to impact your well. So we're going to list this as a medium risk, something we need to be aware of, but something we can't just overlook. So it takes us to our evaluation of impacts to the environment. Again, as I said earlier, the 72-hour test did not include any monitoring of springs or wetlands. So that's going to be an issue here, because you pump this well, we don't know what's really going to happen. Is there going to be pumping influence to to this small ARC1 stream? Is there going to be impacts to the wetlands? So we're going to flag those as data gaps. I guess the good news here is there's no special designations. It's not a trout stream or anything, but again, we just don't know if the withdrawal is going to be impacting these surface water features. As far as RTE species, the PIND evaluation did have a hit as far as a conservation measure for a timber rattlesnake. So we're not going to consider this a data gap. Again, it's a conservation measure. There's some recommendations, but the withdrawal is not going to impact the habitat for this species. So ultimately, the conclusion here is that there is going to be a risk to the environmental resources because we just don't know what pumping that well is going to do to the stream or the wetlands. So when you look at this table, it's not as friendly as some of the earlier tables. You know, there is a high risk to the sustainability as we presented. There's a high risk to environmental resources based on the fact we don't have any testing, monitoring during the testing. The other users, again, not a lot of them, so we rank that as a medium risk, but there are users out there that could be impacted. So the conclusion we come to is that we cannot use the existing data to support renewal at the rate of 101, which brings us to, well, can the data be used to support any quantity? And the concern we really have here when we look at the drawdown data was the exposing of the water-bearing zones and the declining yield in that well. We don't know that we can't use the existing data to come up and recommend any specific recharge or withdrawal rate for this well. But what guidance can we give as part of this action plan? So that will take us to our next slide here. Ultimately, there's a three-step process we recommended for this project sponsor. Some further evaluation is definitely needed here for this well. Going to need to do some short-term testing or potentially some well rehabilitation work to be able to identify what you think a sustainable rate is. Ultimately, then you would discuss the results of that with your consultant, or even give us a call. We'll talk you through it. But we're going to need to see then step two, some longer term testing at that proposed rate to fill in the data gaps, because we still have the data gaps we identified with potential impacts to the stream, potential impacts to the wetland, other users out there that we don't know if are going to be impacted, and the big one here is we really don't know. We're seeing the water-bearing zones being exposed, and we believe that's causing a problem. What are you going to do? Will the rate you're proposing be protective of those water-bearing zones to make sure your withdrawal is sustainable? Ultimately, once that additional testing is done, then we'll look that information will be used in step 3 as part of your alternative hydrogeologic evaluation to be able to answer the 3 principal risk factors and identify what a rate is that will be protective of all those features that we typically look at. So we'll pass, at this point, I'll pass it back to Mike, and he will share our final example with you.
All right, this last example that we have is also a little bit unusual. It identifies certainly some problems, just like the last one, but we end up with a significantly different result. So I'll go through this one fairly quickly because there's a couple of things that just really aren't as significant for this project. And we can work through a couple of the risk factors fairly quickly. It's just from a background perspective, it was a 60,000 gallon a day well that it was approved in '89, has been in use since that time. There is a small stream nearby, but there's really no other sensitive environmental features to be too concerned about. The available data that we have was a historical test, but it was a constant head test. So it was kind of unusual to see a constant head test done. And this was one of the last wells developed of a group of wells. And the other wells that they have are actually fairly similar to this one also, that they're relatively low capacity, small and medium capacity sources that once the drawdown hit an important water bearing zone, the water levels would start to decline rapidly. So I think they switched from doing constant rate tests to constant head tests to try to assess whether or not maintaining a specific withdrawal rate through a period of time was going to work out. So what they ended up recommending in that original test was a withdrawal rate of 61 gallons a minute. Now, obviously, 60,000 a day is not the equivalent of 60 gallons a minute. So what we ended up approving it at was about 41 gallons a minute. So we reduced it further than what those recommendations were at the time. We had some operational data, but again, like the other projects, we had a long period of withdrawal data, but only about 8 years of water level data. What makes this project a little bit different is that the operator developed an informal operations plan. So they recognized that water levels would decline very quickly when they hit certain levels. So as they started to approach those levels, they would start to reduce their withdrawals. And that was a very astute observation, and it was a good resource or management of that resource to recognize that they needed to cut back to make sure that they weren't causing any kind of harm to that well. There were the historical tests included a couple of observation wells. There wasn't a whole lot observed during those, and the public water supply does serve the entire area. So we had the distribution map available. We also looked at PWSAP data. And again, like the other projects, we're looking at the PNDI results and current use of environmental features. So the conceptual model that we have was started to be developed just based on the formation. And the formation here is very important. We have schist and phyllite, which tends to not have a very good transmissivity. So we're dealing with a low transmissivity aquifer. So you often have small areas of influence, but you often have significant drawdown associated with them. And that's kind of what you expect with a small to medium capacity well, such as this one and the other ones that are in their system. The well that we're actually looking at is the one that's on the southern part of this area. You can see it's kind of at the headwaters of a small tributary, but I think the headwaters, where it actually becomes intermittent, is even further downstream. So it might be mapped as a stream up here, but it's not normally flowing. This is most likely semi-confined, although there is probably an unconfined element to it because there are a lot of shallow water-bearing zones, and water-bearing zones decrease with depth. So even though we have a storativity that indicates a semi-confined aquifer, there probably is some shallow connection there. We looked at the groundwater availability, and surprisingly in these areas, the recharge rates are a little bit higher than you might expect. I think what happens here is that the saprolite is fairly thick, so it's able to absorb some water and then it slowly discharges it, so it can help support base flow during lower flow conditions. But you're still dealing with a low transmissivity aquifer. So overall, the groundwater availability was there to support the previously approved rate at 60,000 a day because there weren't any other significant withdrawals within this basin. There's only a 1 square mile basin, but it's not like we're looking at a carbonate aquifer and a high transmissivity well that could possibly do as much as 1,000 gallons a minute, even though it might be a small basin. There is significant resource or sufficient resources to support this. So kind of moving on from that, then we get into this historical testing, because this is really where some of the most interesting parts of this project are. And these graphs are very hard to read, so I don't expect anybody to really be able to see too much off of this. But if you're able to look at that step test graph, it does indicate that where some of the water bearing zones are, that possibly a lower rate should have been utilized from that step test. And when you end up projecting that step test data out, maybe something more like 20 to 40 gallons a minute might have been more appropriate for a long-term rate. But then they started the constant head test out at 91 gallons a minute and ended up at 65 gallons a minute by the end, and then recommended that 61 be approved as a sustainable rate. Then when we started looking at the operational data, it really started to demonstrate an entirely different story. So we have some water level data for the first couple of years there, and you can see that there are routinely below that white or that light blue line, which is the upper water bearing zone. Then they often hit the second water bearing zone. And these are withdrawals that are less than 40,000 a day. So that's not even getting up to the approved quantity. The most that they've ever used this well is at 51,000 on a 30-day average. So we're starting to look at this, and this is establishing some real concern for us. And as we're evaluating this well, we're trying to balance what they've been using, which is about 50,000, compared to what the operational data seems to indicate as being sustainable, which might be 30,000 to 15,000 because of what they've done during drought periods. So you can also see that during this period of record, their withdrawals have changed significantly. You know, they bounce around quite a bit, and that's most likely because the project sponsor recognized the value of some of those shallow water bearing zones and tried to maintain water levels above it. So they responded appropriately to what they were seeing with water levels in their well, as well as the production that their well was providing. So what do we do about this for sustainability? The historical testing data isn't great. Probably suggests that a lower rate should have been approved. We did approve a lower rate than what was tested, but the operational data seems to indicate that for sustainability purposes, something even lower should be considered. There really wasn't anybody around to be impacted. Everybody was within the public water supply system, so we didn't spend a lot of time on impacts to other users. And really the same thing with impacts to the environment. There was a very small area of influence, and the surface water feature was actually outside of that. So we were able to get past those fairly quickly. So the summary with this one comes down to the withdrawal at 60,000 a day isn't sustainable. The operational data indicates that even 51,000, which was their maximum, isn't sustainable. So we need to figure out some way to work through this. To do that, we recognized what the project has been doing. We would recommend that they formalize their operations plan. But then we also had to recognize that they have a connection with a public water supply system that is with an appropriate capacity to offset the losses from this well and the other wells within their system when the resource isn't available. So they planned appropriately, obtained the other sources that they need, and so they utilize this source and their other sources, their other wells, when the resource is there, and when it's not, they utilize that interconnection. So we needed to recognize that as part of this project. So we actually recommend approval at a rate that wasn't sustainable because they had sufficient resources available to make up for it. And the project was operating the well appropriately. So it seemed to make sense to recognize that. So this is one of those odd cases where there's a data gap. We're recognizing that there's a potentially high risk for one of those risk factors, but there's no data that they would be able to collect that would actually fill that gap in. They have all of the data. We know that there's already sustainability problems, so we're not recommending that they collect any additional data. So this is one of those cases where they've got everything that they needed. They were operating the well appropriately, so the approval really needs to continue with that and recognize how they've been doing that. So that's kind of a quick example about how something can still be a higher risk, but may be okay in the end. So if you have a project like that, I would recommend not just working through it and submitting it like that. That's probably one you'd want to talk to us about as you work through this and start to recognize some of those differences with this project. This is unusual. We don't see this type of situation very often, but we can make some allowances for it when there are the right circumstances. And this project just happened to have the right circumstances. So we do have a certificate of completion that we're able to offer There's information here on your screen that will be available again at the end of this webinar. So I'm going to move on from this screen because I want to get into a very quick demonstration of the online forms for the AHE, because we did make some changes to that. You can find those forms here at this spot, and I'm going to switch over to form quickly, and we'll work through this. There's a couple of things that as this comes up that I would want to remind everybody about, that we do have instructions embedded in the form. So please take advantage of that. I think that's a fairly underutilized component of this, and those instructions can be found here at this README. We also have a link to the policy available, and there's also a help button off to the side. And again, I think this is another underutilized aspect of the form. This will send a message directly to IT when there's some kind of technical problem with the project. I think most people just contact commission staff, review staff about any kind of issues that they're having with the forms, and that's fine. But this is an alternative way of getting through that process. So a couple of things to show you. We have the PCI process. That is something that's new. The project contact information form replaces the old Form 72. We've had that in place for a couple of years now. As you work on the PCI, it'll populate section 1.1 here and tell you who you are. Project fee type is something that you're going to, if you are a municipal project, you're going to need to get an access code from us. So as you're working through this, you can get that at any time. Just contact commission staff and we'll do that. We've pre-populated a form here to give you some examples of the types of things that we are generally looking for. So in this case, there's a well field exemption. This is a relatively new field. When you click yes, you'll get this message that pops up asking you for a couple things. If you don't already have a well field determination from us, then you'll need to upload a request and justification for that well field determination. If you do have a well field determination, we can provide you with an access code to zero out the invoice for this. Most projects at this point probably don't have the well field determination, then you would need to provide an upload, and that's generally what it would look like. So moving down through this kind of quickly, a couple of uploads you'd have: facility location, project narrative. I did want to talk about section 1.34 here a little bit, because this is the overall facility use. So this is about the entire project. So it's not just about the one source that is the subject of this form. It is about everything involving your project. Then we ask for specific information about the source here in section 1.4. What we often see is a confusion between 1.34 and this section, where people are putting either in the same information, or they might have it inverted, where we're getting the total facility location or project information here instead of just the source itself. Moving down through this, a couple options for well construction logs. You might have the driller's log and the geologist log. If you don't have both, one is fine. If you don't have either, you can upload a statement that says that no well logs are available for this project. Wanted to bring attention to some of these selection boxes here. So for the water bearing zone, it's not always intuitive to people about how to work through this. So as you work through it, you enter the appropriate information about what the water bearing zone is. And then as you get that information in, you hit add zone. And you'll end up with this table starting to populate here that actually starts to summarize some of that. If you need to add another water bearing zone, you just come up to the top here and start entering in information for that second zone. And then once you hit add zone again, you'll see that pop up. And it's a similar thing here for the static water levels. So you see there's a couple that are already entered here. And if you need to add another one, you just enter that information and move on. Moving into the groundwater availability analysis section, this is something that most people should be familiar with. This is very similar to what we've had for many years, so I'm not going to go into this in any detail. What I do want to point out is this plus button down here at the bottom of it. When you hit that, you'll get another row. So if you find yourself running short on rows, hit that plus symbol and you can get another row to enter. Most of what you're going to be doing within an AHE is going to be in section 4. This is really the meat of everything. So I've provided a couple of example uploads that you might have throughout each of these things. Generally speaking, what we're looking for is section 4 is going to provide us with all the information that you've used to assess that the project is at low risk for all the risk factors and allow us to come to the same conclusion that you're reaching. So this is where you're going to provide all that data. You get the rare, threatened, and endangered species. You do those in environmental surveys. Make sure it's signed when you upload it. And then if there's any agency responses that are necessary, you can put any correspondence that you've had with those agencies, or if you don't have a resolution of some of that yet, you can upload a statement that indicates as much. Working down through the environmental resource assessments, we're looking for an environmental screening here. So this is your summary of what is within the area, and you can start your assessment of impacts to those here. You can provide some data if you'd like to, or you can address that down here in each of the risk factors. So very quickly, we have some examples of what might be provided. At a minimum, each of these sections should contain some kind of summary for that risk factor that indicates why this is or is not low risk. If there is higher risk, hopefully you've either done some kind of operational testing and you're going to include that as part of this summary, or you're going to provide some recommendations about how to deal with the low risk aspects of it, or how to deal with the risk. And it may be that, for example, it impacts the other users. You would end up with a mitigation plan and say, well, we've only used the well at 181,000. We really want the 365,000, but we think there might be a problem with this nearby well, so we'll drill them a new well, and we can deal with that part during the application. So there's ways to manage some of those things. Similarly, with impacts the environment, you're uploading these materials. Finally, what we're looking for here is for the AHE summary. It is what it sounds like. It's a summary of what you would expect to see of your conclusions of the AHE analysis. And hopefully at this point, by the time you're uploading this and getting ready to submit, you've got everything completed so that there's no risk, or you're able to mitigate all the risks associated with it. Section 4.5 is a new section that gets us the professional geologist signatures. So what we've been dealing with over the years is kind of spotty compliance with Pennsylvania's and New York's geologic requirements, where you're supposed to sign and seal all the documents. And that's been happening in some cases and not in others. So what we did, we took a step here to kind of universalize all of that. This is going to be a required field when you're initially submitting. So you fill out who you are, stamp it. If you're in New York or Pennsylvania, Maryland does not require this yet. And finally, then we have some miscellaneous uploads that you can do. So we're going to go back to the PowerPoint. And at this point, it's a good time to enter any questions that you may have in the chat feature. I'm going to hand it back over to Todd here in a couple of minutes, but there's a couple of things that I would like to wrap up here, hopefully fairly quickly. You've seen this slide before with the additional resources that are available regarding the AHE process and the groundwater renewal process. So please avail yourselves of those. I want to mention that our next public water supply assistance program offering is what we're expecting to be a consultant workshop. This is going to be an in-person workshop here at the commission office. We're looking for probably 25 to 30 people in more of a classroom style, where hopefully we can take some of these action plans that we've worked on and provide these as exercises to people that attend, so that they can actually work through the project, see what we see, and see how they come up with something. Maybe there's some different ways of evaluating it maybe we didn't consider. So we're looking at a half a day for that. We are hoping to get a New York PG continuing education credits for that. That's a new process to us, so we haven't worked through all the details of that. It's not a guarantee at this point, but that's what we're hoping to be able to do. So the summary that we've got here is, see on the right, here's the process for getting back to or submitting your certificate of completion request. You get that information over, and Dave will take care of that in a couple of days or a week or so. But he'll respond to everybody that wants a certificate. But what we'd like you to take away from this webinar, as well as the previous one, is to start this process early and to contact us often. We are available to help you with any questions you may have. We know it can be a complicated process. There's a lot of moving parts, and it can be difficult to digest all of it. And so part of what the AHE process is intended to do is break the renewal process into manageable pieces. And that's why we are focusing on sustainability, impacts the other users, and impacts the environment. We think that those are manageable parts that hopefully are a little bit easier to wrap your head around. We want you to utilize the data that you have and only collect data that if you really need to support that renewal. We want to make sure that any data collection is targeted. And as Drew said in his initial message during the opening for our first webinar, we really want to make sure that projects are getting through this process as efficiently as possible and just doing what is necessary without doing a whole lot of extra work. At one time, the aquifer testing process was the gold standard, and it still is for new projects. But we really think that through good data collection and management of the resources, that many projects are going to have the type of information that they need to support a renewal through the AHE process by collecting routine operational data. So with that, I'm going to turn it back over to Todd to see if we have any questions in the chat.
Great, thanks, Mike. Before we get started on the questions, I just want to say a few things in case anyone drops off before the end. We want to thank all the attendees for participating in today's part 3 of the final webinar of this 3-part AHE process webinar series. And I mentioned previously the recording of today's webinar will be made available on our website and emailed to participants in the next coming days. Mike mentioned the in-person AHE process workshop that's going to be offered at the Commission headquarters on May 25th. We're really looking forward to that event, and stay tuned for more information in the next couple of weeks. As always, please do not hesitate to reach out to Commission staff with any additional questions or for more information. We like to make ourselves available and help projects get prepared for renewals and submittal of applications. So thank you for your continued interest in our Public Water Supply Assistance Program. And I think we are getting a few questions, and we'll go to those now. Like the first question, and I think I can actually answer this and at least start out. Our voluntary action plans, alternative hydrogeologic evaluations, and or waivers that have been submitted to the Commission or developed by SRBC staff, are they available as public information? So these could be requested through our request for access to records. The policies on our website, it's a fairly straightforward policy. I think if you're interested in a particular one, because there is, I think, kind of a follow-up question to that one, if there were any submitted for wells in this person's area, it might help them to evaluate their well. In that situation, I think I'd probably reach out to maybe Mike Appleby or Scott McFeeters and make an inquiry about if there were any projects that had this done already in their area. So that's probably at least a good first step, and then they can help you with submitting a request for records access. Let's see. See if there's any other questions here. There's a question here. Can you put up the screen for obtaining the certificate? Mike, maybe, I don't know if you can. There we go. That should help you out.
Yeah, we can leave this up for a few minutes after, as people are leaving the webinar, if there are no other questions, and also.
Yeah, if you have any other questions, you can go ahead and enter them in here. Otherwise, I like to say during every opportunity, we really encourage pre-application meetings. Pre-application meetings are a good way to start even before you start working on a alternative hydrogeologic evaluation or a voluntary action plan. Staff can assist you in just the process and even helping to identify available information that the commission may have on your particular project. So you can reach out to any member of staff, request a pre-application meeting, and we can set something up to help you. So I'm not really seeing any other questions. So I guess at this point, we'd just like to thank everybody again for participating, and keep a lookout for information on our upcoming May 25th workshop. And we look forward to seeing participants at that event. Thanks a lot.